Let's begin our discussion of cranial nerves by doing the following cranial nerve overview. We'll give some background by talking about the nervous system light, where nervous system consists of a pathway for sensory neurons to take information in to the central nervous system, where interneurons process, and then motor neurons take out appropriate information to muscles and glands. And sensory neurons come in, and in cranial nerves, we have three different types of sensory neurons. The first is one that you're probably already familiar with. We know it as general sensation, or it's called GS. This deals with things like touch or painful sensation, like you touch a flower or then you touch a hot stove, which then gives it painful and temperature sensation, or vibration, taking a tuning fork and placing it on your finger, you feel it vibrate, or proprioception, sensory neurons in your joints and ligaments that let you know if your knee is bent or a tendon has tension on it. They're called general sensation because if I were to take an ice cube and put it on your forehead, put it on your foot, or drop it down your shirt and your back, it's going to be cold. So the same type of general sensation around. We also have special sensations like hearing or taste or vision or smell. Now these are special sensations or special senses, SS, because you only hear in your ear, you only taste on your tongue, you only see in your eye and smell in your nose. It's not as if you decide, it looks like a very pretty flower, I'm going to smell it, and you put your great toe next to it. The only place that you have sensory neurons that will transduce chemical sensation to an electrical chemical impulse is in your nose. The only place that you can taste chemicals from your beverage to let you know that that's orange juice and not water is chemical sensation, chemoreceptors on your tongue called taste buds that will transduce that chemical energy into an electrical chemical impulse. And then the other type of sensory neurons for cranial nerve are called visceral senses or visceral sensory, VS. And this is where sensation is something that you're not conscious of, like baroreceptors with regards to change of pressure in a vessel, or chemoreceptors of change of chemical like oxygen or CO2 in the blood, or stretch receptors like in the gut tube. Now, interneurons for processing. We've talked about interneurons for reflexes and spinal cord. For cranial nerves, the primary place where interneurons are going to then process information is in the brainstem, which consists of the midbrain, where cerebral aqueduct is located, or the pons, or the medulla oblongata. And then next down is the spinal cord, but when it comes to interneurons processing cranial nerves, midbrain, pons, medulla. Then motor neurons go out. So there's two types of motor output. One is voluntary because it goes to skeletal muscle. Now, there are two different types of skeletal muscle in the head. Some muscles are derived from branchial arches. So we describe motor neurons that innervate muscles derived from a branchial arch, branchial motor, like muscles of facial expression or muscles of mastication or hind arch muscles that's illustrated in this picture. Also, muscles derived from somites, so somatic or somatic motor. That should say SM, not BM. And there's somatic motor. Then we also have visceral motor. This is then things like glands, like your salivary glands, the parotid gland indicated, or lacrimal glands make you cry. They're also known as parasympathetic because these are now pathways that are giving rise to parasympathetic origin, where remember that parasympathetic origin is cranial sacral. Well, now the cranial nerves are going to be the vehicles to distribute these parasympathetic neurons. So what are these cranial nerve modalities that we use this term? Well, sensory neurons then have the following three modalities. General sensory for touch, temperature, pain, vibration. Special sensory, sight, smell, taste, hearing, and balance. And then also visceral sensory, baroreceptors, stretch receptors, and so forth. So then these sensory neurons send information to the brainstem. That's where the part of the central nervous system that processes, and then an appropriate motor response through the motor neurons. And there's three different types: somatic motor, skeletal muscle derived from somites like tongue muscles or eye muscles; branchial motor, skeletal muscle derived from branchial arches like muscles of facial expression or mastication, or your traps and sternal traps and SCM. And then visceral motor, what's innervating salivary glands, that parasympathetic innervation. So let's do some examples. For example, the oculomotor nerve, cranial nerve number 3, it has 2 types of motor neurons within that nerve. Somatic motor that goes to eye muscles, visceral motor that then has parasympathetic to pupillary sphincter muscles that constricts your pupil. Or facial nerve, it's going to do special sensation taste and branchial motor to skeletal muscles of your face, thus facial expression, and also visceral motor to all the salivary glands in your lacrimal gland. Or your vestibulocochlear nerve, that all it does is hearing and balance. The key to this is cranial nerves are a nerve. A nerve is a collection of neurons. And then when it comes to what can be found in the neurons, it all depends. But here's your menu of sensory and motor cranial nerve modalities that each cranial nerve can possess. So a terminology reference where it comes to sensory, general sensory is the same as general somatic afferent. That's a term you'll hear, and I just think it's really long and confusing. Special sensory, special visceral afferent, visceral sensory, general visceral afferent. I'm making a mention of this because those longer words are ones you'll see in the literature. I'm only going to say general sensory, special sensory, visceral sensory, and the same goes to motor in the sense that these are terms that you'll read in literature, but I use these simplified terms because it makes more sense. This is only meant to be a reference. Now, a segmental pattern where peripheral nerves, like cranial nerves and spinal nerves, have a segmental pattern. So, for example, the midbrain gives rise to cranial nerves 3 and 4. The pons gives rise to cranial nerves 5, 6, 7, and 8. And then the medulla gives rise to cranial nerves 9, 10, 11, and 12. But then you just keep going in a caudal fashion. Then you have the C1 spinal nerve and the C2 spinal nerve and the C3 all the way down to the S5 and coccygeal spinal nerves. The take-home point to show in this picture is that there's a segmental pattern to cranial and spinal nerve origins. Midbrain, you start off in this rostral area with cranial nerve 3 all the way down to the sacral level of the spinal cord. So let's show this rostral caudal numbering again in this inferior view of the brain. There's cranial nerve number 1, your olfactory nerve. That's for smell. Cranial nerve number 2, your optic nerve. That's going to be for vision. Cranial nerve number 3, oculomotor nerve. That's going to give rise to muscles that move your eye. Cranial nerve number 4, trochlear nerve. It's a nerve that gives rise to one muscle of the eye. Trigeminal nerve gets its name because it has 3 branches, V1, V2, V3, the letter V meaning 5 for trigeminal, the number nerve, and there's the ganglion. Cranial nerve number 6, abducens nerve. Cranial nerve number 7, facial nerve. Cranial nerve number 8, vestibulocochlear nerve. Cranial nerve number 9, glossopharyngeal. Number 10, vagus nerve. Cranial nerve 11, spinal accessory nerve. And finally, cranial nerve 12, the hypoglossal nerve. So here we have all those nerves numbered, where they serve a rostral to caudal or front to back, top to bottom, origin from cranial nerve 1 all the way down to cranial nerve number 12.